for coming to the machine learning seminar on a Friday. It's not our normal time, but we had a very special guest. This is unofficially our first NLP at Georgia Tech seminar. It's not an official thing, but we have a bunch of NLP speakers. So David Bamman will be here today. We have another one on the 25th, December 2nd and December 3rd. So if you're into natural language processing, and I assume because you're here, then make a note on those calendars and you'll be seeing a bunch of advertisements about those. So we're going to go out, we're going to end the year in a bang, end the decade on a strong note. But we're here for David Bamman, and I'm so pleased to bring him here. He's one of the people where I just love reading his papers. They're very near and dear to my heart. He's an assistant professor from Berkeley School of Information, and he works really in the intersection of natural language processing and what I think is the digital humanities, but he looks at a lot of literature. And literature is an interesting natural language processing problem. He'll tell you all about it because unlike, say, Wikipedia, which is much more fact-based, there's a lot of complexity in how people write when they write stories, and as well as social media sorts of things. They don't stick to like niceties of natural language. And David's going to tell us all about how he's been trying to tame the beast of literature. So take it away.
Great, thanks. Okay, so thank you, Mark. Thank you all for being here. Am I mic'd up loud enough for everybody to hear me? Fine, okay, good. How many of you here have either working or have an interest in NLP? I'm glad to hear, oh wow, this is awesome. Okay, great. So what I'm going to talk about today is another application area of NLP that may be a little bit different from the kinds of applications that you're either working in your research or really studying in class, right? Very different from question answering, from summarization, from machine translation. What I'm going to talk about today is the use of NLP essentially as an algorithmic measuring device. As a way of getting us some quantified measurement about some phenomenon that can shed light on questions of literary history, or literary theory in this particular case. I'm using the example of literature here to see how we can use these methods to shed light on this fundamental problem of understanding literature. But it's really also a kind of application that has much broader appeal to lots of other areas as well, including not just the digital humanities, but computational social science, computational journalism. Right? Whenever we want to see some signal in text and extract that using these algorithmic measuring devices. This work is in collaboration with Matt Sims, Ted Underwood, Sabrina Lee, Jerry Park, Sejal, Popat, and Sheng. And I point out it really couldn't have happened without having collaborators who are coming from literary departments. So that includes my postdoc, Matt Sims, also Ted Underwood and Sabrina Lee, who are both in English at the University of Illinois. Okay, so let's jump in. Now, how many of you have read a book in the past month? Wow, this is surprising that there's so many of you. When I was in grad school, I mean, there's no shame in this. When I was in grad school, I focused on NLP for literature, and it was very rare for me to have any time to read an actual book. For those of you who haven't read a book in a while, this is what a book looks like. This is Moby Dick. And there's a lot of ways in which the kind of language we see being expressed in books, in novels, in literature in general, is very different from the kind of domains that we typically study in NLP, right? Very different from news, very different from product reviews, very different from tweets. One thing that distinguishes literature is its length, right? So books on average are about 200,000 words long. Right, that complicates a lot of the kind of standard algorithms that we use in NLP for things like coreference resolution. Right? Coreference is essentially quadratic in its complexity with the number of entities that you want to co-resolve. Right? So if at any given point you want to compare with all of those previous entities you've seen to see which one you want to link to as being the most similar. Books also, and literature also, tend to have very long sentences. Right? So the average sentence length in the Wall Street Journal is something like 20 words. The average sentence length in literature is about 40. But it's not quite so evenly distributed. Right? When we're talking about why this matters for questions of parsing. Right? So parsing has a computational complexity that's cubic in the length of the sentence for constituency parsing. And for an average sentence in the length of 20 words, that's fine. But when we have sentences that stretch those boundaries and get to the maximum length in literature, like 100 words or 1,000 words, that complexity really blows up and effectively making these kind of methods really unsuitable for this task. Literature also is complicated by its use of figurative language. Right? It uses metaphor and depictions of this imagined space that's very different from the kind of neo-Davidsonian semantics we have for expressing propositional structure and content in these sentences. So literature is very different in many ways from these kind of domains that we typically study. Literature has also been used in a couple of different ways in NLP. Right? So one way in which literature is used as being a source of data. Right, so if any of you here have used BERT in NLP, BERT has been amazingly successful for a lot of tasks. Right? We're essentially raising the state of the art by 5 points on average for a number of different tasks in NLP. BERT is trained on Wikipedia. It's also trained on the books corpus. Books corpus is about 7,000 or 8,000 novels that are self-published. So it's a really large source of data that these kind of contextual language models are really learning a lot of information from about the state of the art of the real world. Narrative QA is another data set that we see fiction being used for the use of this task of question answering, for trying to answer questions that have to scope over a much larger context than just a single Wikipedia article or a single news article. We see fiction being used in common sense stories by work by Nasreen Mustafazadeh and others. This is a creation of a data set of 5-sentence stories where one task is trying to predict how the story ends. It's also being used as the fundamental data that drives a lot of work in semantic and syntactic change, right? Using the Google Books dataset in particular to see how words have been used historically over 200 years to see how those words have been changing in their sense meaning. At the same time, there's a lot of work in modeling specifically literary phenomena. That includes my own work at trying to model character types in literature and in movies. It includes work by Mohit Iyer and Stina Chaturvedi and others in looking at the relationship between characters in novels. Trying to have models that capture sentiment or a plot, some representation of plot that can be either as simple as sentiment or something more complex. And also even getting into questions of character psychology, right? How it is that characters have specific motivations for the kinds of actions that they're performing that we have observations for in these kinds of data. So these are two different sort of dimensions in which we see fiction being used in NLP right now, right? Where these kind of papers are being published at venues like ACL, EMLP, and NACL. There is, however, an entirely different sphere of research that we see this kind of work being driven in terms of computational methods for reasoning about literature. And that's work in the computational humanities. This here is a snapshot of some of my favorite work in this space. Just to call out two examples of what this work looks like from a literary perspective. Ted Underwood has great work in measuring how much time is elapsing in the span of a given piece of text. So within a given paragraph, is there 1 minute that elapses? Is there 10 minutes that elapses? Is there an hour? Is there a year? Is there a century? Right? Can we go about predicting from one piece of text how much time is being elapsed in that piece of text? Holtz-Kozma also has great work on measuring how loud a novel is, where loudness in this case is very much tied to the specific verbs of speaking that introduce quotations. So if you go about establishing a measure for every individual word that can introduce a quotation, saying has a score of 5 of not being particularly loud or particularly quiet, while shouting has a very loud score. So if you measure what kinds of verbs are being used to introduce quotations, you can get a sense about how loud that sort of audio environment that's being captured in the context of a given novel. So there's a lot of work that's being driven by fundamentally literary questions here that's using these methodologies that you have been developing in this space of NLP to really drive some insight into the fundamental problem of literature. Now, what I'm going to talk about here in this very beginning is give you one case study for how we can use NLP to drive literary insight about a specifically literary phenomenon, and then talk about ways that we can develop more complex NLP models that can capture more complex questions that we might want to ask that can drive different forms of insight. And the question that I want to get to here is this fundamental difference between the depiction of men and women in fiction. Between the depiction of what male characters do and female characters do over 150 years of literary history. Now, this fits into a lot of other work in gender bias right now. Right? We know that there's a gender bias that really creeps up every time we have a system that's been trained on data. And that it really impacts other kind of questions like the representation of different genders in different data sources, right? So we know in particular that only 15% of Wikipedia biographies are of women. So even just the quantified nature of how many biographies are of women is very imbalanced in this particular data set. We know that even looking within those biographies, that women tend to have much more emphasis being given to these acts and events of marriage and divorce than men. We know that bias creeps up implicitly in any kind of model that's trained on natural language, right? So word embeddings incorporate this kind of bias very famously. That includes kind of cultural bias that's implicit in the kind of natural language use where we're incorporating the kind of bias that exists in reality in our depiction of the words that we use to describe it. And this kind of bias that creeps in for word embeddings also propagates to a lot of other downstream NLP tasks, right? Including coreference resolution, sentiment analysis, and even speech recognition, right? So bias is pervasive in these kind of data sets. The question of whether or not there is this same sort of unevenness, this uneven representation of gender in literature is really fundamentally a problem of measurement. And what I want to do here is to really try to explore if we can design an algorithmic instrument that can transform a single novel into a quantity that really expresses the depiction of gender. Right, and this is like the big picture what I think a lot of this kind of class of methodology really captures, of trying to take an entire novel or an entire long document and reduce it to a single number, right? To take all of Tom Sawyer and reduce it to the single number 0.53. Now this may seem very reductionist, right? But in many cases, this kind of reduction is what we need to do to test specific hypotheses, to be able to articulate this specific research question in a way that can be answered in this context. And part of the art of designing these systems is how we go about incorporating the kind of knowledge that we have about these phenomena and about these specific data sets and domains that can let this number be informed in an intelligent way. So the way that we're going to get at this number for text is to, again, reason about these core objects that we want to make claims about. And that's characters, right? We want to see whether or not there's an uneven distribution in attention being given to male and female characters over the course of these novels. This here is dependent on character. So what we need to do in this case is use these methods that are being developed in NLP to reason about what a character is, right? To identify and define a character, and then have some measure of what we count as being attention. So attention we can measure in lots of different ways. But we're going to measure attention here as the amount of screen time those characters get in a novel. And we're going to find screen time to be the amount of things that those characters do and have done to them. There are a lot of other ways that we could go about defining what attention is. We could define it by the amount of dialogue that a speaker has. We could define it simply as the amount of characters who are of a specific gender. Across all of these different dimensions, we see these results end up being the same as I'm going to describe. But what I'll end up describing here is this specific operationalization where attention is the set of things that characters do and have done to them. So to this, we're going to rely on an NLP pipeline that I developed a few years ago for really applying all of these individual steps in NLP to book-length documents that can get past some of these hard problems of computational complexity as a function of the length of these objects. So that includes parse speech tagging, named entity recognition, dependency parsing to get at the specific attributes of what characters are doing and having done to them, character name clustering to resolve different mentions of characters to the same unique thing, pronominal and affluent resolution, which can link specific mentions of he and she to the characters that they're associated with, and also quotation attribution to link the specific mentions of a character to the dialogue that they're speaking about. And all this is up on GitHub right now and has been for a while here. And the way that we'll go about representing a character, again, with this operationalization that we define a character as being the set of things that they do, have done to them, also the things that they possess and the things that are predicated of them. Looks like this, right? So we have an entire representation where we know who the unique characters are through character name clustering and coreference resolution. We have a way of representing what they do as a function of their syntactic dependencies. So Tom Sawyer here is the agent of paints. He's the patient of being kissed. His paint brush belongs to him, and he's predicated as being a rascal. Right, so this here is the set of unique things that is used to describe this individual character. And if we take all these individual counts of these specific relations, add them all up, that gives us a single number for Tom Sawyer. Tom Sawyer here is being reduced to the single number of 216. Okay, so that gets us to what we can use to see whether or not we have a difference in performance, difference in attention being given to male and female characters here. Once we have this operationalization of a single number along with the gender of those characters, we'll see if we can see any significant differences. So to this, we'll apply this to a data set of 100,000 narratives from the HathiTrust Digital Library. All of these were published between 1703 and 2009. All of this data comes from university library scans, right, where the books have been scanned in a university library and then OCR to extract the text. Each one of these books is then subjected to that same pipeline that I just described. And we'll also have an additional set of 10,000 narratives from a separate data source from the Chicago corpus that's published from a different time period. And I'll describe how that can corroborate some of these results. Okay, so what do we see here? When we take this very simple measurement, right? Once we have a way of operationalizing what attention is for a character, what we can just do is count up the amount of attention we have for a character given their gender being female and normalize that by the total count of attention for all characters. Right? And this is the plot that we have over 200 years of literary history. What we end up seeing is that overall, men tend to be focused on much more in literary novels than women do, and that also tends to be going down over time, right? And only possibly being corrected with the rise of second-wave feminism in the 1970s. Right? That's one theory we might have here. Now, if we had an even representation, we would see a number that's closer to 50%, right? 50% attention to male and female characters. The fact that this is below this line means we have more attention being given to male characters than to female characters. We might postulate that this is something to do with just a specific data source, right? With just the HathiTrust. And if we plot this same measure of attention for this separate corpus with a separate time frame and separate selection criteria, we see it overlapping this same pattern, so corroborating to a more or less even a good degree in this kind of context. We might ask, though, if there's reasonable differences that come about as a function of the authorship of these books. And we have good reason for thinking that. Because if we look at how many books were published by men and women over this space, we see a very similar pattern. And over this course of 200 years, we see from the very beginning of the 19th century that there were as many men and women authors of books. And that tendency tended to go down over time, only to somewhat be corrected in the 1970s. Right, it's a very similar pattern here. There used to be many more women authors, and that tended to be overrun by male authors as time went on. We might have good reason for thinking why this is the case, right? So there's been a lot of work investigating exactly why this phenomenon happened of women being edged out of publishing in terms of over the course of this time period. Before 1840, as Tuchman and Fortin point out, at least half of all novelists were women. But by 1917, most high culture novelists were men. They attribute some hypotheses for why this happened include the fact that in the early 19th century, fiction was not yet a very high status career, right? But after 1840, it increasingly brought status, which brought more men into competition, right? Into taking over these roles from women. Also, one possible effect here is that terms of publishers' contracts ended up becoming more disadvantageous toward women in this time period, which edged women out of this publishing space. And also, on the more positive side, there were other careers beside novelists that were opening up to women. So women didn't just have to be restricted to this one kind of profession. There were other opportunities that were opening up that let them go out of this market instead of just having pressure from men going in. So we see here that there is this effect of potential changing distributions of what the authorship looks like here that might have some effect on the measure of attention that we have for male and female characters that we see captured in these novels. And in fact, if we look at this same distribution, but separate out this finding of the attention being given to male and female characters as a function of the gender of the author, what we find is something very striking. That looking over the same time period, women, as authors, end up allocating equal attention to male and female characters, right? Much closer to 50%. While men, as authors, end up allocating 3 times more attention to male characters than to female characters, right? It's a finding that may be very obvious in retrospect, but it's something that really is only driven by the fact that we have empirical data to give us this kind of signal and tease apart this distinction. Right, once we have some measurement of what a character is, have some way of measuring what attention to a character looks like, and then factorize this space as a function of the gender of the author, we see this really radical disparity, which we wouldn't have seen beforehand. So this process has told us something fundamentally new about literary history. We know something new now that we didn't know before. So the takeaway from this case study, first of all, is that we can use these methods of NLP to generate new insight for literature, right? It's possible to do this using these kind of computational methods that you're developing here. But at the same time, we know that there are a lot of research challenges in NLP that we need to overcome in order to drive more complex analysis. And the kind of more complex analysis that I'm thinking about here can really be articulated with this graph from XKCD. So you guys are all mostly grad students and professors. I'm sure you know what XKCD is. But this here is an example of the plot structure that's being visualized for Lord of the Rings in the context of this comic. And if you ask what this plot structure is, we can see that whatever plot is, right? Plot is this very complex, nebulous abstraction. We don't know really what plot is. But what we do know is that it has to involve a certain set of individual atomic components. Right? We know that plot has to involve people. Right? And in this case here, we see plot lines being defined by people who are doing the same thing together at the same point in time. So in this case here, this is the plot line of Merry, Pippin, Sam, Frodo, and Bilbo, who are all together at Bilbo's party with Gandalf, end up together with Aragorn at Weathertop, end up at the Council of Enron with all these other people too. Right? The plot lines here are defined by people who are doing things together at the same place at the same time. This is a level of complexity that we would like to get to help drive our understanding about literature that we really can't quite get at with the state of the art in NLP right now. Now, what my group is doing is trying to take this really complex abstraction and decompose it into these individual structured elements that we know need to be a necessary part of it. Each of these individual parts also has an existing NLP application that can help drive this kind of work in this area. So this includes, we know that plot has to involve characters, right? And characters involves this fundamental task of entity recognition. We know that plot has to involve events, right, of characters doing things. So this corresponds with this task of event detection. We know a plot has to involve setting, right, the places where these events are taking place. That involves entity recognition again, and possibly also setting coreference. So even if a place isn't named, we know that it's the same place as another place where other events happened earlier on. We know in many cases plot also needs to involve objects, right? In Russian folktales, magical swords and potions are really important for advancing plot. That's important for this NLP task of object detection and coreference resolution. And we know that plot also needs to involve time, right, which also corresponds to the fundamental NLP problems of temporal processing and event ordering. Now, the issue with all these different existing steps in an NLP pipeline is that when you take a lot of this, look at the state of the art for a lot of these individual methods in NLP right now, you can see the state of the art is actually getting quite high. Right? We can say that the state of the art for a task like tokenization is essentially 100%, right? In English, by construction, because we define what a token is and write regular expressions that can identify them. Part of speech tagging now is up to about 98%. NER is about 93 for the F-score. Parsing, constituency parsing is up to about 95.1, which is quite amazing. And coreference is the straggler in this bunch, but it's still not entirely unrespectable, with an F-score of 73. Now the problem with all of these states of the art, however, is that they're essentially being defined on a very small domain of text. And I don't mean just news like CNN and the Wall Street Journal. I mean specifically the 1989 Wall Street Journal. Right, this is one of the dirty secrets of NLP, that a lot of these benchmarks have really been optimized toward one very narrow domain. Because of the rise of the pen tree bank back in the early 90s, a lot of other layers of annotations have been placed on top of this to give us onto notes and other sources. So a lot of our focus still is on contemporary, not even contemporary, news from 30 years ago. If you look at this measure of attention, we see the Wall Street Journal getting probably the most, but there is a long tail of other domains that have been getting more attention recently, right? Including Twitter, product reviews. It's down in this long tail where we start getting other languages like French and Mandarin, but there really exists a very long tail of domains, genres, and even individual authors like Mark Twain, where we'd really like this entire NLP pipeline to work better on. Because one thing that we know in looking at a lot of these different tasks in NLP is that if you take a model that's been trained on one domain and apply it out of the box on another, you see an incredible drop in performance. Right? So this is true for English part of speech tagging, taking a model trained on the Wall Street Journal in this work, this is a meta-study I'm giving you, gets an accuracy of 97% on the Wall Street Journal. Take that same model, use it to take Shakespeare, accuracy drops to 80%. You take a model trained on modern German newspapers, the accuracy for POS tagging is 97%. Use that same model, apply it to early modern German, it drops to 70%. Take a model trained on the Wall Street Journal and apply it to Middle English, the accuracy falls by 45 points. There's no reason why this should work for Middle English. Middle English is nothing like contemporary English, but we can still see that this drop of accuracy is really calamitous. This is true for Italian part of speech tagging, moving from news to Dante. It's true for English, moving the Wall Street Journal to Twitter. It's true for English NER, moving from news to Twitter. It's true for phrase structure parsing, moving from the Wall Street Journal to medical text, moving from the Wall Street Journal to patent data, and moving from the Wall Street Journal to magazines. Right? Across all of these different pairs of domains, we see a drop in performance of about 20 absolute points, right? Effectively rendering a lot of these tools unusable. Right? This is a fundamental problem that we have. Now, we have a lot of strategies that we could use to address this problem. Right? So this includes work in domain adaptation. Right? So trying to take a model that's been trained on one domain, adapt it slightly so that it works on another domain, right? Either given a small amount of data in the new domain or no domain data at all. The use of contextualized word representations really has mitigated some of these effects, right? If you have a model that really adapts your representation of a word to its specific context of use, that really can capture a lot of nuance that you wouldn't have had otherwise. But if you really care about having NLP work better for a specific domain, and that domain happens to be literature, one thing you can do, the most straightforward thing you can do, is just create more data in that domain. So that's what I'm going to be talking about here. We've done this here in this context for entities and for events, also for coreference and quotation attribution in progress. This data set here for entities and events is up on GitHub right now. I'll give you the link at the end of the talk, but the rest of this work is going to be probably published by the end of this year. So all this data is going to be up for you to be able to use yourself. Okay, so let's start first by talking about entities, and literary entities in particular. Now, we use entities in this character work, right? An entity here is this fundamental atomic unit that we're trying to take measurements about. Right? We define a character as being all of those co-referent mentions, where each one of those mentions needs to be recognized on its own. So in the context of Tom Sawyer, the entity, the literary entities here, as people, would be Tom, that boy, I, Tom, the old lady, and even the room, right, as being a location/facility. Now, a lot of our work in NLP really focuses on the specific subtask of named entity recognition, right? Where you're looking for specific mentions of specific categories like people, places, organizations that are explicitly named. And if you take this passage from Jane Austen's Emma, these would be the two names that are pulled out of this passage, right? So Mr. Knightley and Isabella, nothing else. But we know, however, that there are a lot of other entities in these kinds of texts that are not named that are still going to be very important to reason about. So even in this one passage, we have the entities of Mr. Knightley, a sensible man about 7 or 8 and 30, that is 37 or 38 for those of us who speak modern English, a very old and intimate friend of the family, Isabella, Isabella's husband, and the elder brother of Isabella's husband. Right? We want to be able to extract all of these individual common entities as well, in addition to the named entities. And we might want to do this for lots of reasons, like establishing coreference. Right? All of these things that are grouped in this box refer to the same fundamental entity. The family, Isabella, and Isabella has a husband refer to separate entities. Now, when we formulated in this task of trying to recognize spans of text that correspond to arbitrary entities, we can't rely on the same assumptions that named entity recognition does in terms of having flat, non-overlapping structure. Because even in this context here of the elder brother of Isabella's husband, we have nested entities that we need to be able to recognize. So in this context, we're in this different application area of nested entity recognition, which entails slightly different methods from NER on a flat set. So what we've done here is annotated a new data set of about 200,000 words of 100 different books that are taken from Project Gutenberg that come from a mix of literary styles, including a high literary style epitomized by Edith Wharton's Age of Innocence, Joyce's Ulysses, and popular pulp text too, including King Solomon's Mines and Alger's Regedic. Has anybody read King Solomon's Mines? It's essentially Indiana Jones. It's a story that Indiana Jones was based on. Regedic is one of the most, Horatio Alger is one of the most popular artists in the early 20th century. All of his books, and he wrote like 100 of them, are all essentially the same. They're all rags to riches stories about kids who pick themselves up by their bootstraps and learn to make it in the world. So we have this really broad range of styles that we see being captured here to really get at the different ways in which we can see these entities being expressed. We select the first 2,000 words from each of these texts and then annotate them for all of the entities that they contain. And the entity classes that we're using are the same ones that were originally used in the ACE 2005 specification for NER. That includes people, so single persons with proper names or common entities or sets of people, organizations, formal associations, vehicles like ships and wagons and carts and things. And locations are where things start getting interesting from this perspective of entities, because we have a distinction here between geopolitical entities, right? Those entities that contain a population, a government, a physical location with political boundaries. Natural locations that have physicality but don't have political status. And facilities, right? And these includes structures that are built by people that have a level of granularity greater than a single room in a house, right? So a kitchen would be an example of a facility. A house is a facility. A street is also an example of a facility that's being built by people. And there are a couple of places where the kind of choices that we make for how we go about annotating these entities becomes really complicated by the fact that we're annotating literary text in particular. One of these comes in the context of metaphor, right? Because in a lot of cases for the standard news data sets where you see these kind of nested entities being annotated, it becomes very straightforward how you go about annotating sentences that have this kind of copular structure. Right? John is a doctor is very straightforward to annotate because John is a person and a doctor is a person. Right? So the things that are predicated of a given entity tend to be of the same class as that entity. In literature, we have complications like this. The young man was not really a poet, but surely he was a poem. So we know here that the young man is a person. We know that a poet is a person. What is a poem? Does a poem become a person because it's asserted of this individual? In our case, we make the decision that we only annotate phrases whose types denote that entity class. So here we would say a poem is not an example of a person. We also have complications from personification. So this here comes from Sewell's Black Beauty. As soon as I was old enough to eat grass, my mother used to go out to work in the daytime and come back in the evening. Anybody read Black Beauty? What's the problem here? Who is my mother?
I feel like it's an animal.
It's a horse, yes. So in this case, too, we make this assumption that a person, in our definition of it, is any character that has either internal monologue or some evidence of cognitive capacity. Right? So it includes characters who have engaged in dialogue or who have some reported internal monologue, right? Regardless of their human status. So this importantly includes aliens and robots in science fiction as well. Right? If they engage in dialogue, we treat them as being people because we care about them as being characters. Okay, so in the end, we have about 13,000 entities that we've annotated according to these standards in 200,000 words. And by far the most frequent of these are people. And in fact, if we look at the distribution of these entities with respect to existing news data sets, we see a very stark difference. Right? We have a lot of people being mentioned here. We also tend to have many more people, as we can see here in this person category, compared to the ACE annotations for news. Right? There are many more people being mentioned in literature compared to news. There are many more mentions of geopolitical entities in news compared to literature. We have many more mentions of facilities like houses and rooms in houses than literature does, or sorry, than news does. And so given this kind of distribution, we can ask this kind of question of how well we can find these entity mentions in text as a function of the training domain. Right, if we didn't go through this process of annotating all of these texts, how well could we have taken a model trained from news to recognize these entities in our particular data set? So to do this, we're going to take a state-of-the-art model from 2018, a layered bidirectional LSTM CRF. It's state-of-the-art on ACE 2005. And then evaluate this performance difference when we alter the training and the test domain. So if we take a model here, this bidirectional LSTM CRF that's layered, train it on ACE of news, and evaluate it on ACE, we end up with an F-score of 68.8. right, which is more or less state of the art for this particular problem. If we take this same model and then use it to evaluate on our new literary data, we see, again, a drop in performance of about 25 points. Right, again, effectively rendering these kind of tools more or less useless for this kind of task. Right, so dropping down to an F-score of 45.7. If, however, we take a model that's been trained on the training portion of our data and evaluate it on the test portion, so the domains are the same, we see an increase in performance that gets us back up to the level of the original ACE evaluation. And in fact, if we then go one step further and take a model that's swapping out the BERT, so the static word embeddings with BERT contextual embeddings, we see an increase in performance of about 9 points here. Right, just by making this one static change. Taking static word embeddings, swapping them out with contextual ones, lead to a dramatic increase in performance. Now, we can also, given this kind of model, we can also ask, what is it learning about itself that we can distinguish its own performance from that of other models trained on different things? So to do this, we tagged entities in 1,000 new Gutenberg texts using these two models. One trained on news, one trained on literature, and then analyzed the difference in frequencies with which a given string is tagged as a person under both models. And when looking at the difference in which strings are tagged more under the model trained under literature compared to news, what we find is that the strings that are tagged most include the term misses. The second most common is miss, the third most common is lady, the fourth most common is at. Now, we can see why this might happen, because when we look at news, there just tends to be many more mentions of men in this particular data set that ACE is defining and training entity recognition models on, compared to literature. Literature has many more mentions of female characters as opposed to male characters. So to make this more concrete as a testable hypothesis, what we wanted to see here was how well does each model identify entities who are men and women? Right? Is there really a disparity in the performance when we look at the accuracy of these different models with respect to them being able to recognize men and women in these kind of data sets? So to do this, we annotated the gender for all person entities in that test data that we've just been testing on, and then tried to measure the recall of each model with respect to those entities. And what we find here is that a model trained on ACE ends up having a very stark disparity in performance in terms of whether or not it can recognize men and women. So the recall for ACE trained on news for men is about 50%, for women it's about 38%. Right? So overall, we know this performance is not good, right? Compared to overall, we know that it generally cannot recognize entities that well. But even given the fact that it can recognize entities well, it recognizes women even worse than it does for men, right? By 10 points. Taking our model trained on literature, we see overall a much better performance, right, as we expected, we saw before. But importantly in this context, we also don't see a disparate impact in being able to recognize men and women. Right? They are more or less equivalent in terms of our ability to recognize them both. So not only can this kind of data really help us measure these kinds of spans of entities in this new kind of data set, but also has better performance in terms of their lack of disparity between these two different classes. Okay, so let's talk about events now as being this other form of plot structure that we know we need to get at. But yeah, question?
Quick question.
Yeah.
So you talked about going from ACE to lit.
Yeah.
Have you done lit to ACE? Does it transfer back?
We haven't tried that yet. We also haven't tried using the BERT contextual embeddings on the ACE to see how well it does on literature. I would expect that the graph would definitely close. I don't think it would close by 25 points though. Yeah. Okay. Let's talk about events, because there's been a ton of work in NLP over events overall. Right? There's a ton of work in thinking about events as they show up in news for event trigger detection, for slot filling, for measuring whether or not a given author has a specific belief in the factuality of that event. There's lots of work in grounding events in time, in constructing narrative chains and inferring event schemas in an unsupervised sense, and also work here in these labs in trying to use events as a way of conditioning new text. Right? Start from some event and generate text that corresponds to that event kind of structure that we want to see captured. There has been a lot of theoretical work on this too, right? In terms of conceptualizing what the metaphysics of events looks like. That goes back to work by Aristotle, Bertrand Russell, Whitehead Quine, all the way up to more recent work by Davidson and Dowdy. But one way of thinking about it at a very simplified level, what an event really captures across a lot of these different formulations is that event really is a thing that happens, right, under this realist view. right? If you see, adopt this realist view that we care about events that actually transpire in the world. An event is a thing that happens, right? A thing that happens with reality. Events in language are typically realized through verbs. Right, so you often see them in this context of he walked down the street, but there's lots of other ways in which we can see an event be realized as well. Right? An event can also be a nominalization, like he had a nice walk, that fundamentally corresponds to some real action that transpired in the real world. Now, in our context, we care about those events that are depicted as actually happening in the course of literature. Right? There is no real world here that we can ground any of these events to. They're all still this depicted imagined space. But we want to have a way of thinking about this distinction between events that are depicted as happening versus those that are depicted as not happening. And thankfully, we have a lot of formal theoretical structure that we can use for making this kind of distinction. One is to facet these kind of events by their polarity. So polarity specifies whether an event is asserted as happening or is asserted as definitely not happening. So in this context here, John walked by Frank and didn't say hello. We know in this case the walking is depicted as happening, but the saying is depicted as definitely not happening. Right? So it's not just that we have an action, that is a verb in this case, where we have two verbs that correspond to events. We care about just those ones that are depicted as actually transpiring. The walking here and not the saying. So positive here is depicted as taking place, negative is depicted as not taking place. Tense also gives us some information, right? So I walked to the store and will buy some groceries. The walking happened, but the buying has not happened yet, right? It may happen at some point in the future, but at the moment of articulation of this sentence, the buying has not happened. Only the walking has. Specificity also is another dimension that we can use for faceting events in this more complex way. So specificity captures whether or not a given event corresponds to an action that takes place with respect to a specific individual at a specific place and time, or if it describes an action that involves an entire class of individuals. So in my case here, my son just watched Frozen is an example of a specific event because it involves my son, who is a specific person. Well, if I say kids like Frozen, it's not an event that actually has transpired in the world, right? It's a predication we say about a general class of individuals and not something that happens to any specific one individually. So specific here is a singular occurrence at a particular place in time. Generic is a claim about groups or abstractions. The more complex facet here is the epistemic modality of verbs. And in this case, the epistemic modality gives us a way of deciding whether or not the event is asserted as actually happening in the epistemic reality of the pragmatic context. So if I say I walked to the store to buy some groceries, again, the walking happened, but the buying here has not. Right? It signals my intent, but it hasn't specified whether or not I have successfully bought those groceries. There may be some evidence in the future. The next sentence may say, I did buy those groceries. And we can say this in this case, the buying happened at that point. But at the moment of articulation here, this buying is not asserted as actually happening yet. Modality lots of different ways in which we can express this kind of epistemic modality. One is by looking at beliefs, right? So in this case, rumors of my demise. The demise here is not asserted as actually happening, right? The person has not demised. It is only a rumor of that. Hypotheticals, if you visit Berkeley, try cheese board. The visiting here has not taken place yet. John was ordered to return the book or face a fine. The ordering happened, but the returning did not, or it's not asserted as actually happening. I threatened to release the photos. The threatening took place, but the releasing did not. And desire. So she wants to go to Rome. The wanting takes place, but the going does not. Right? It's not asserted as actually taking place here. So we have a couple of different dimensions at this point that we can go about annotating individual words, individual tokens in this same data set for whether or not they correspond to the same category of realist events, right? Of events that are depicted as actually happening in the literary space of the novel. So once we have this kind of data set, we can carry out the same predictive task, right? For two different sentences, for a given sentence here, can we go about predicting whether every individual token corresponds to a specific realist event? So in this context here of David Copperfield, my father's eyes had closed upon the light of this world 6 months when mine opened on it. In this case here, we want to be able to make a prediction that the closing and the opening are both events that actually happened, while in a separate sentence like call me Ishmael, we want to predict that the calling did not happen because it's an imperative, right? It's not something that actually is being expressed as really happening in the context of a novel. So what we'll do here is develop a couple of different methods for going about predicting whether every event has actually transpired in a novel, given these data sets that we've annotated. So the simplest baseline is a very simple one, but also one that many people who aren't skilled in NLP would just immediately jump to, right? And say every verb that we see in a book is going to be defined as an event. We can measure how well this performs by comparing against the test performance. It ends up getting really good recall, right? Quite high recall, but not perfect recall, right? Again, because 23% of all tokens that are events are not verbs, right? They're nouns and other forms of expressing this kind of action. But the F-score here is also quite low, 29. If we take a model that's featurized, right, and add some learning on top, we can have a way of featurizing every individual token according to the word identity, the part of speech, the context around that word in terms of unigrams and a bag of words and n-grams generally. We can use information about the WordNet synset and its place in the WordNet hierarchy. We can also use dependency information, including the dependency label and the head of that word. And also information about whether or not the noun phrase that it's adjoined to is a bare plural or not. Right? This gives us, in principle, some information that's useful for deciding between generic and specific mentions. We take this model, run it through a simple L2 regularized logistic regression. We see that it ends up performing much better than a simple baseline, right, up to about 57 points for an F-score. But it's still a very simple model, right? Still a very featurized one. What we can then do is use more complex machinery. In this context, a bidirectional LSTM with a CNN on top of it, and a subword CNN to give us a representation of words that we don't have word embeddings for in word embeddings that we've learned from a domain-specific collection of 15,000 English Project Gutenberg texts, and also add a sentence-level CNN on top of this. What this structure looks like here is that we start out with the individual word tokens at the bottom, have a word embedding plus the representation from the subword character CNN, put that into a bidirectional LSTM, and output from that a direct representation to the prediction along with a CNN that's scoped over all of those outputs for the entire sentence. If we have this kind of representation and see how well it performs, we end up seeing that it does about 8 points better than that featurized model. Right, so having this kind of contextual information that comes to us from its use in the context of a bidirectional LSTM, along with these representation of word embeddings that we get from Gutenberg, ends up leading to a pretty much better performance than a featurized model. Again, we can then substitute these word embeddings that we get from Project Gutenberg text, these static embeddings, swap them out with BERT contextual embeddings, and see how well this model performs. And what we find again is the same dramatic improvement that when we swap out these BERT embeddings that are not even fine-tuned to the domain or the task, just swapped out for the BERT, for the Gutenberg static embeddings, we see an increase in performance here by 9 points. So one takeaway from a lot of this work is that BERT is pretty amazing for a lot of these sentence-level prediction tasks, right? Increasing the performance here across these domains by about 9 points on average. Okay, so what would we want to do with these kind of events as a representation of data? One thing that we could do, as the simplest descriptive case, is just measure the abstractness of a novel by the density of those realis events. Right? So which novels have more things happening? In our particular data set, we see that it tends to be more of the lowbrow books that have more things happening, like The Quest of the Silver Fleece, The Invisible Man, right, sort of action, adventure type novels, while books like The Magnificent Ambersons, in our context, had absolutely no realis events. Right? It depicts a more high-level narratological description of the state of the world and not any actions about specific characters in that world, right? At least in these 2,000 words. We can also measure the distribution of events over narrative time. In our particular case, events, tend to be many more people who are mentioned at the very beginning of a book and many more actions that happen toward the end. So this here is the distribution of where these events occur in the context of a novel. In terms of the narrative time, they tend to show up much more frequently at the end. Finally, we can also ask what the relationship is between these events and external signals like prestige. Question, yeah?
So the numbers for the high one, for the 0.1, was that 10% of all verbs are actually happening, or 10% of all words?
The number of the, sorry.
The previous slide.
Oh, yeah. So no, these are 10% of all tokens in the first 2,000 words. Yeah. Yeah.
Is that a function of the first two? Is it the full text? Over, like,
So this one is a function of the first 2,000 words. This one's a function of the full text. Yeah. Okay. So the last thing we can do is ask if there's a relationship between these events and other external measures about these books. One thing we can look at is prestige. Right? So prestige is something that's been characterized in a lot of different ways in a computational sense. Mark L. G. Hewitt and others at Stanford have defined prestige by inclusion in Stanford exam lists. Right? So if you're a PhD student in English in Stanford, if a book shows up on a list of books you need to read, it has high prestige. Ted Underwood makes a different claim here that prestige is defined by being reviewed by an elite literary journal. Right, so if you have a set of journals that you know are elite, everything that they mark as being prestigious, or as being reviewed, is prestigious by default. 50 Shades of Grey here would be an example of a book that has probably low prestige. It hasn't won any awards in that context. While The Milkman by Anna Burns is a novel that we can think of as having high prestige. Right? It won the Man Booker Prize in 2018. So looking at just these prizes, we can see that there is a we can at least separate out these different classes of books into being high prestige or low prestige. In our case here, what we're going to do is use this metric that Ted Underwood defined, right? It's saying that we have a set of authors that are identified in this work as having the highest or lowest prestige, as measured by the number of times their works are reviewed by these elite literary journals. This gives us 150 high prestige novels and 188 low prestige novels. And if we count up how many events happen in each of these different categories of these high prestige novels and low prestige novels, we end up seeing that high prestige novels have a much lower ratio of realist events happening. Right? They have much lower density of these kinds of actual depictions showing up in their context. This here, so on average, high prestige novels have events showing up at a ratio of 4.3%, while low prestige ones have them happening at about 5%. So again, these are the 95% confidence intervals here, which shows that they're significant. But more than looking at just their individual ratio, we can also see the distribution of these ratios over all of these books that we're evaluating. And what we find in this case is that when we look at this distribution, high prestige novels have a lot of flexibility in determining how many events they can see depicted. So this ranges from anywhere from 2% to up to 6%, right? To a very low frequency of events to a very high frequency of events. While low prestige novels don't have this degree of flexibility. Low prestige novels never get below 3.5% in terms of their density of these events and tend to be much more bunched up together around the 4 and 5 point range. One way of interpreting this is that low prestige novels tend to have less variability in their depiction of these kinds of realist events because they have the pressure of something always needing to happen. Right? Something always needs to be on the page to help capture their reader's attention in a way that high prestige novels just don't have. Okay, so this gives you at least a sense of what we can do with these kind of methodologies when we want to apply them to literature to help drive some insight into literary theory and literary history. All of this data for the events and entities are up on GitHub right now. And like I mentioned, we have a couple of other layers of annotation that we'll probably be putting out at the end of this year. But with that, I'm happy to take any questions with the time we have left. Thanks. Yeah.
Yeah, hi. So, thank you for your talk. It's a very fascinating talk. I have some confusion about like being able to identify women. So I know that the representation of women in literature is not as high as men. Then how is it that the model is able to identify women almost as well as identifying men?
How is it able to identify women almost as well as ours? Oh, I see. So we see that there's less representation, but we're still able to identify them reliably. I mean, I think just because that you can think about this in terms of like the bias coefficient in a logistic regression compared to the feature values of any individual feature. That the base rate is important for some things, like characterizing a depiction of how much attention they get, but it's not important for discriminating between those classes. Right? There's enough information, at least in the textual signal of the sentence, that lets us capture them with equal rates in terms of the tagging task. Yeah?
I was wondering if all the data collected was specified just with books in general, or if you tried to
Yeah, so the criteria that we had for this particular collection was for all books, the books had to be in the public domain, so effectively making them published before 1923 so that we could release them to the public. And within that, we gave our annotators a lot of flexibility of choosing which kind of books they wanted to annotate. So it's not like we had strong guidelines for having a lot of diversity, but it ended up coming out that way as a function of the choice that the individuals made. I should point out too that we're also moving this, we also have a different annotation project going on now that moves a lot of this work to contemporary text. So we'll end up publishing some work too that includes books that are published after 1924. Yeah?
Excuse me. How far is this technology going to go, in your opinion? For example,
Yeah.
using numbers, 40s, 50s, 70s, 80s.
Yep.
Are we going to get up to 99% across?
No, I think this is the problem you see with any kind of task that involves humans as annotators. I think one of the things that I like stressing in my own NLP class is that, for a lot of these tasks that we work on in NLP, like POS tagging, parsing, we're given data sets, right, which define a gold standard. But it's not like those gold standards, come to us ex nihilo, right? They don't just come to us given by some, infinitely knowledgeable source. All of these data sets are constructed by human judgments, right? And so we are the ones as people who construct truth. And because we're the ones constructing truth, that means that there potentially is a lot of ambiguity about what individuals think truth is. So the fact that we have different people disagreeing about what a correct label means that there's always going to be some upper bound on performance that's not 100%. It's going to be a function of whatever you think that upper bound is going to be for people who agree on the value of a label for the same data point. Yeah.
Hey, thanks for the talk. So I have a question relating to when you're talking about, these women being underrepresented in the novels because of different things happening in the society. I'm actually wondering, do you admire or hate the practice of people, let's say, copying some part of underrepresented data in the data set so that the data set can be trained better? Let's say copying every occurrence of women let it happen twice, and they claim that improved the training performance. Do you like it or hate it?
So in this case, so you mean like rebalancing the training data so that you have exactly the same things that are being fed into the training algorithm, but just multiple copies?
Do you feel that it's something that is okay or it's just nonsense?
No, I wouldn't say it's either way. I think that, that kind of method works in some kind of cases when you have really strong class imbalance for the things that you're predicting. But in our case here, and in a lot of these kind of cases where you have underrepresentation, I think what you want to have is better diversity in the representation of those individual examples, which you wouldn't have by just copying the same examples twice. Yeah.
In the one slide where you had, you were comparing the recall precision and F1 score for ACE-lit and lit.
Mm-hmm.
So when you're talking about precision recall and F1, you have something that you decide this is my positive and everything else is negative.
Yeah.
What were you considering your positive, and how did you come up with just a general, like if you're multi-class, how did you get a general F1 score for the whole?
Sure. Yeah. So the standard way of doing this for the NER task is to say that you can either calculate F-score at a macro level or a micro level. So in this case, we could report all the F-scores for the individual classes, right? Say, how well did we do on recognizing people or facilities or locations? Or we can say, as we presented this slide, with a given label with a given span that you predicted, did you get the span right, and did you get the exact category right as the truth? So all of those count. If you get that exactly right, it counts as being correct. And if you don't, then it counts. And either way, it counts toward the denominator in calculating precision and recall. So it's the correct span and the correct label.
We take one more question?
Yeah.
I'm curious about the intersection of the bias line of work and then also the event detection.
Mm-hmm.
Specifically, are you considering like operationalizing things like the Bechtel test and looking at like in what context women appear and what they're doing in those contexts versus men?
Oh yeah, for sure. So we have looked at that in the same paper where we described what this what this difference in, the fact that we have a difference in the amount of attention to male and female characters as a function of the gender, we also characterize what was different about them, what they were doing that was different, and how that ended up changing over time. One of the things that we observed was that like the physical descriptions of male and female characters ended up being less discriminating. If we tried to take a model that would take the actions that a character did and predict whether that character was a man or a woman, as time went on, that became a much harder task. Right? Even if we take the same size data set, the same feature representation space, as time went on, men ended up doing more things that were like women, and women ended up doing more things that were like men.
What about character interactions? Have you looked at that as well?
Character interactions. We haven't looked at character interactions. What would be interesting to look at there?
I think so. I think for movies, the Bechdel test is looking
Yeah.
at that there is at
Yeah.
least two female, and then they also speak to someone
Yes.
besides each other.
Right.
So that would be, I think
Ah.
that's a harder topic.
Yes, yeah. Yeah, so actually, we do have some work going on right now in trying to measure information propagation in social networks in novels, right? To see how a given piece of information can pass from one person to another and then to another person. And in those kind of contexts, we're also looking at the gender dynamics of how that information spreads. It doesn't quite get at the Bechdel question about whether or not this criteria is satisfied in a book, but at least gives us some measure of the kind of dynamics that happen in a group setting. Yeah.
That's so great. Thank you very much.
Okay, thanks.